Welcome, weary traveler, to a quiet corner of the cosmos, a place where the universe whispers its secrets and the gentle hum of discovery lulls you into a peaceful slumber. Here, with The Sleepy Scientist. We don't rush through the wonders of the world. Instead, we invite them in, softly, allowing their grandeur to unfurl like a calming dream. Tonight, as you settle in, perhaps nestling deeper into your pillow or letting your eyes gently drift closed, we're going to embark on a journey that delves into the very fabric of your being, exploring the invisible building blocks of everything you see, touch, and feel whispers of the atom, exploring the building blocks of reality. It's a question that whispers of the smallest particles, the deepest mysteries of substance, and the profound solidity of the world around us. As you relax, let your thoughts drift, much like the unseen particles that constantly dance around us. Imagine the solid ground beneath you, the gentle weight of your blanket, the firmness of your pillow. Everything around you feels so tangible, doesn't it? So permanent. Yet, if you could shrink yourself down, smaller and smaller, far beyond what your eyes can see, you would discover a world of astonishing emptiness and ceaseless motion. It's a breathtaking thought, isn't it? And it's this very mystery that prompts our gentle inquiry tonight. We won't rush to the answers. Instead, we'll explore them with the same slow, deliberate pace that the universe itself maintains in its subatomic dance. This isn't about memorizing facts, it's about understanding, about feeling the profound elegance of reality at its most fundamental level, and letting that understanding guide you towards a truly restful state. So, breathe deeply, let your muscles soften, and prepare to unravel one of the most fundamental riddles of our physical world. Not with effort, but with quiet curiosity. Our story, like many great scientific tales, begins with the core concept that everything you perceive, from the tallest mountain to the smallest grain of sand, from the vast oceans to the very air you breathe, is made up of incredibly tiny, fundamental particles called atoms. Imagine them as the universe's ultimate, invisible Lego bricks. They are so incredibly small that billions of them could fit on the head of a pin. You can't see them with your naked eye, or even with most powerful microscopes, yet they are the silent architects of all matter. The idea that matter is made of tiny, indivisible particles is ancient, dating back to the philosophers of ancient Greece, who called them atomos, meaning uncuttable. For centuries, this remained a philosophical idea. But through centuries of patient scientific inquiry, experimentation, and observation, modern science has amassed overwhelming evidence that atoms are indeed the fundamental units of matter. We can now detect them, manipulate them, and even image them, though indirectly, using incredibly advanced technologies. Now, here's a truly astonishing fact about atoms despite the apparent solidity of everything around you. An atom is, for the most part, empty space. Imagine holding a solid rock. It feels dense and unbreakable, doesn't it? Yet, if you could somehow magnify the atoms within that rock to the size of a football stadium, the nucleus, the very heart of the atom, would be no bigger than a pea at the center of the field. The electrons, which are even smaller, would be whizzing around in the vast, otherwise empty stands. The rest, the overwhelming majority of the atom's volume, is just empty space. Think about that for a moment. The very bed you're lying on, the very floor beneath it, your own hand resting quietly at your side, all of it is predominantly empty space. Yet, It feels solid. This apparent solidity arises from the incredibly fast movement of the tiny electrons and the powerful, unseen forces that govern their interactions, preventing the atoms from passing through each other. It's a testament to the power of fundamental forces that this almost entirely empty space feels so remarkably solid and real to our senses. This concept of an atom, mostly empty space, yet forming the basis of all tangible reality, is one of the most counterintuitive, yet profoundly beautiful, truths in physics. It challenges our everyday perceptions and invites us to look deeper, to understand the universe not as it appears, but as it truly is at its most fundamental level. Every whisper of sound, every ray of light, every texture you feel, is a consequence of billions upon billions of these invisible, mostly empty, building blocks interacting in a ceaseless, silent dance. Imagine, as you relax deeper, the world around you dissolving into a shimmering, vibrant cloud of countless tiny atoms, each one a minuscule universe of almost entirely empty space, yet working in perfect concert to create the illusion of solidity. Picture these atoms, silently dancing and interacting, forming the very substance of everything you perceive. This quiet, persistent truth about the atomic nature of matter is the very first secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all existence. Let the image of countless invisible atomic bricks, gently humming with unseen motion, settle peacefully in your mind. This is the origin story of all matter, a journey that begins with the fundamental composition of everything around us. Feel the quiet power of this unseen architecture, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atoms, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into whispers of the atom, exploring the building blocks of reality. In our last quiet chapter, we settled into the astonishing understanding that all matter is made of incredibly tiny atoms, and that these atoms are, for the most part, simply empty space. Now, as you drift even deeper into your serene state, let us journey to the very heart of the atom itself, to its dense, powerful core, the nucleus, where almost all of an atom's substance resides. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine that vast, empty space within an atom. At its very center, holding almost all of the atom's mass in an incredibly tiny volume, is the nucleus. Think of the nucleus as the atom's central sun, a minuscule, yet extraordinarily dense, powerhouse. If our atom were indeed the size of a football stadium, the nucleus would be no larger than a tiny pea or a marble, resting right on the 50-yard line. Yet, this tiny pea-sized nucleus would contain nearly all the weight of the entire stadium-sized atom. It's an incredible concentration of matter and energy. This compact, dense nucleus is made up of two primary types of particles, bound tightly together: protons and neutrons. Protons. Imagine these as tiny fundamental building blocks that carry a positive electric charge. They are the defining characteristics of an atom. The number of protons in an atom's nucleus is what determines its identity as a specific chemical element. If an atom has 1 proton, it's always hydrogen. If it has 6 protons, it's always carbon. If it has 8, it's oxygen. This unchanging number of protons gives each element its unique chemical fingerprint. Think of protons as the identity cards of the atoms, making each one distinct. Neutrons. These are the quiet, neutral companions to the protons within the nucleus. As their name suggests, neutrons carry no electric charge. They are electrically neutral. Despite their lack of charge, neutrons are roughly the same size and mass as protons. Their crucial role is to act as a kind of nuclear glue. Remember, positively charged protons naturally want to repel each other, pushing away like the similar poles of two magnets. Without something to hold them together, the nucleus would simply fly apart due to this immense electrical repulsion. Neutrons. Through a powerful, short-range force we'll explore later, provide this necessary binding force, stabilizing the nucleus. They are the silent peacekeepers, ensuring the nucleus remains intact. The fact that protons and neutrons, collectively called nucleons, are packed so tightly together in such a tiny space means the nucleus is incredibly dense. Imagine squeezing the mass of an entire aircraft carrier into a volume no bigger than a grain of sand. That's the kind of density we're talking about within the nucleus. This immense density means that the forces holding the nucleus together must be extraordinarily powerful, far stronger than the electrical repulsion between the protons. The nucleus is the very heart of the atom's identity and stability. Its positive charge, determined by the number of protons, dictates how many negatively charged electrons will orbit around it. And these electrons, as we'll see, govern how atoms interact to form molecules. The stability of the nucleus, maintained by the neutrons, ensures that matter itself is stable. Without stable nuclei, there would be no enduring atoms, no consistent elements, no solid objects, and ultimately, no complex chemistry or life. Imagine, as you relax deeper, this incredibly tiny, dense nucleus at the very core of every atom in your body, a silent, powerful star in a miniature universe. Picture the protons, holding their positive charges, and the neutrons, quietly binding them together, creating the stable identity of each element. This quiet, yet profound structure of the atomic nucleus is the very second secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all substance. Let the image of countless tiny nuclei, silently holding the identity and mass of all matter, settle peacefully in your mind. This is the enduring core of all existence, a journey that begins with the fundamental composition of everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atomic hearts, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler, as we continue our gentle exploration into whispers of the atom, exploring the building blocks of reality. In our last quiet chapter, we journeyed to the very heart of the atom, its dense nucleus, understanding it as the tiny central powerhouse composed of protons and neutrons. Now, as you drift even deeper into your serene state, let us focus on one of the most fundamental particles within that nucleus, the proton, the tiny bearer of positive charge that gives each atom its unique identity. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine a single atom, perhaps one of the countless atoms that make up the very air you breathe. At its incredibly dense core, among the tightly packed particles, is the proton. Think of the proton as the atom's identity card, its unique fingerprint, or perhaps even its soul. The number of protons within an atom's nucleus is what fundamentally defines which chemical element that atom is. This is known as the atomic number. Consider the simplest of all atoms, hydrogen. Its nucleus contains just one proton. If you have an atom with only one proton, no matter how many neutrons it has or how many electrons are orbiting it, it will always, definitively, be hydrogen. This single proton is enough to give hydrogen its distinct chemical properties, making it the most abundant element in the universe, the building block of stars and water. Now, imagine an atom with two protons. It immediately ceases to be hydrogen and becomes helium. Helium, with its two protons, has very different chemical behaviors than hydrogen. It's a noble gas, incredibly stable and unreactive. Move to an atom with 6 protons, and you have carbon, the versatile element that forms the backbone of all known life on Earth. An atom with 8 protons is oxygen, essential for breathing. This principle continues throughout the entire periodic table. Each element, with its unique set of chemical characteristics, is defined by its specific, unchanging number of protons. The proton also carries a positive electric charge. Think of this positive charge as an invisible little beacon, constantly radiating outwards from the proton. This positive charge is incredibly important because it is what attracts the negatively charged electrons to orbit the nucleus, holding the atom together. It's like an invisible gravitational pull for tiny charged particles, ensuring that electrons don't simply fly away from the nucleus into the vast emptiness of space. The number of positively charged protons typically matches the number of negatively charged electrons in a neutral atom, creating a perfect balance of charge, making the atom electrically neutral overall. The proton is not just a counter of identity, it is also a source of mass. While incredibly tiny, protons possess a significant amount of mass compared to electrons. Along with neutrons, they contribute almost all of an atom's total mass, giving atoms their heft or weight. This mass is crucial for atoms to form stable structures, allowing them to clump together to form molecules, then gases, liquids, and solids. Without the proton's mass, the world as we know it would be a very different, insubstantial place. Imagine the silent, tireless work of these tiny protons within every nucleus, each one a unique marker, faithfully carrying its positive charge, meticulously defining the identity of every single atom in the universe. From the single proton in a hydrogen atom in a distant star to the complex nuclei with dozens of protons in the heavy elements found in Earth's crust. They are the silent, fundamental architects of chemical diversity. Their unwavering identity and positive charge are the bedrock upon which the vast and intricate world of chemistry is built. Consider the profound implications of this simple particle, the unique properties of each element, why oxygen is a gas, why iron is a metal, why gold is precious. All stem from the number of protons in their atoms. The proton, in its elegant simplicity, is the ultimate classifier, silently dictating the fundamental nature of every piece of matter in the cosmos. It's a testament to the universe's elegant design, where a single tiny particle holds such immense power over identity. Imagine, as you relax deeper, the countless, minuscule protons within every atom around you, each quietly broadcasting its identity, shaping the very nature of the elements that compose your world. Picture these tiny, positive charges, drawing electrons into their orbits, creating the stable foundations of all matter. This quiet, yet profound role of the atomic proton is the very third secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for chemical diversity. Let the image of protons, those silent definers of identity, settling peacefully in your mind. This is the enduring core of all existence, a journey that begins with the fundamental composition of everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atomic hearts, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into whispers of the atom, exploring the building blocks of reality. In our last quiet chapter, we focused on the proton, understanding its pivotal role as the positively charged particle that defines each atom's unique identity. Now, as you drift even deeper into your serene state, let us turn our attention to its silent, equally crucial companion within the nucleus, the neutron, the unseen glue that holds the atomic heart together. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine that incredibly tiny, dense nucleus once more, packed with positively charged protons. If you recall, like poles of magnets repel each other. Protons, all carrying a positive electric charge, would naturally try to push each other away with immense force, without something else holding them together. The nucleus, the very core of every atom, would simply explode from this powerful electrical repulsion. This is where the neutron steps in, playing a vital, unassuming role as the silent peacekeeper. Think of the neutron as the atom's quiet diplomat. It carries no electric charge. It is electrically neutral. This neutrality is precisely what makes it so indispensable to the nucleus. Because it doesn't have a positive charge, it doesn't add to the repulsive forces between protons. Instead, it provides a powerful, short-range attractive force that binds both protons and other neutrons together. This incredibly strong force is called the strong nuclear force, and we'll explore it in more detail later. For now, imagine the neutrons as providing a kind of nuclear glue, holding the positively charged protons in check, preventing the nucleus from flying apart. Neutrons are roughly the same size and mass as protons, meaning they also contribute significantly to the atom's overall weight. Remember, the nucleus contains almost all of an atom's mass, and both protons and neutrons are responsible for that heft. So, while protons define an atom's identity, neutrons contribute to its bulk and, crucially, its stability. The presence, or absence, of neutrons also leads to a fascinating concept known as isotopes. Imagine you have a hydrogen atom, which, as we learned, always has one proton. Most hydrogen atoms in nature have no neutrons, but some hydrogen atoms can have one neutron. This is called deuterium, or heavy hydrogen, and a very rare few can even have two neutrons. This is called tritium. All three are still hydrogen because they all have one proton, but their different numbers of neutrons mean they have slightly different masses. These variations of the same element, differing only in their number of neutrons, are what we call isotopes. Think of it like a family. All the children share the same last name, their identity, defined by the proton number, but some might weigh a little more than others due to varying numbers of neutrons. Many elements in the periodic table have multiple stable isotopes, and some even have unstable radioactive isotopes, where the balance of protons and neutrons makes the nucleus prone to decay. The number of neutrons in an atom can affect its stability, making it either robust or more likely to undergo nuclear transformations. The delicate balance between protons and neutrons within the nucleus is critical for the stability of matter. For light elements, the number of protons and neutrons is often roughly equal. As atoms get heavier and have more and more protons, they need an increasing number of neutrons to provide enough of that strong nuclear glue to overcome the ever-growing electrical repulsion between the many positive protons. Without the neutrons, these heavier nuclei simply couldn't hold together. Imagine the silent, unseen ballet within every nucleus, the positively charged protons, naturally pushing away from each other, yet held firmly in place by the quiet, binding power of the neutral neutrons. These unsung heroes of the atom patiently perform their vital role, ensuring the very stability of the elements that form our world. Their presence allows for the incredible diversity of matter, from the simplest hydrogen to the most complex heavy metals. Consider the profound implications of these tiny, uncharged particles. The stability of every atom around you, from the oxygen you breathe to the iron in your blood, depends on the quiet work of neutrons. They are the essential, silent partners that make the universe's chemistry possible, allowing for the formation of stable atoms that can then combine to create molecules, and eventually, the complex structures of life. It's a testament to the universe's elegant design, where even an uncharged particle plays such a defining and powerful role. Imagine, as you relax deeper, the countless, minuscule neutrons within every atomic nucleus, silently weaving their powerful, invisible bonds, holding together the very heart of matter. Picture these neutral peacekeepers, ensuring the stability and integrity of each element, allowing the world around you to remain solid and unchanging. This quiet, yet profound role of the atomic neutron is the very fourth secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for stability and diversity. Let the image of neutrons, those silent stabilizers of the atomic world, settling peacefully in your mind. This is the enduring core of all existence, a journey that begins with the fundamental composition of everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atomic hearts, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into whispers of the atom, exploring the building blocks of reality. In our last quiet chapter, we focused on the neutron, understanding its pivotal role as the silent, uncharged glue that holds the atomic nucleus together. Now, as you drift even deeper into your serene state, let us turn our attention to the tiny dynamic dancers that endlessly swirl around the nucleus, the electrons, the elusive particles that dictate how atoms interact and create all the vast diversity of matter we experience. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine that incredibly dense nucleus, packed with its protons and neutrons, sitting at the very center of the atom. Far, far away from this tiny core, whizzing around in a vast, mostly empty expanse of space, are the electrons. These are incredibly tiny particles, far lighter than protons or neutrons, so light, in fact, that their mass is often considered negligible when talking about the atom's overall weight. Yet, despite their minuscule size, electrons are fundamentally important because they carry a negative electric charge. Think of the electron's negative charge as an invisible counterpart to the proton's positive charge, just as opposite poles of magnets attract. The negatively charged electrons are electrically attracted to the positively charged nucleus. This electrical attraction is what keeps the electrons bound to the atom, preventing them from simply flying off into space. It's like a tiny, invisible gravitational pull, but for charged particles, holding them in their intricate dance around the atomic core. Electrons don't just orbit the nucleus in simple, flat circles like planets around a sun. Instead, they occupy specific regions of space around the nucleus called electron shells or energy levels. Imagine a series of invisible, concentric spheres surrounding the nucleus, like layers of an onion. Each shell can hold a specific maximum number of electrons, and electrons in shells further away from the nucleus generally have higher energy. Electrons tend to fill the lowest energy shells first, closer to the nucleus, before occupying higher energy shells. The electrons in the outermost shell of an atom are particularly important. These are often called valence electrons, and they are the true architects of all chemistry. These are the electrons that participate in chemical interactions with other atoms. Think of two atoms approaching each other. Their outermost electrons are the ones that see and feel each other first. These valence electrons can be shared between atoms, forming strong covalent bonds like the bonds that hold water molecules together. They can be transferred from one atom to another, forming ionic bonds like the bonds that form common table salt, where sodium atoms give up an electron to chlorine atoms. Or they can be freely delocalized, moving easily between atoms, which explains why metals conduct electricity and heat so well. This ability of electrons to interact and form chemical bonds is precisely what allows atoms to link together and create molecules. Without electrons, or without their ability to interact in these specific ways, there would be no water, no air, no rocks, no living cells, no complex matter whatsoever. The entire astonishing diversity of chemical compounds that make up our world, from the simplest gases to the most intricate proteins, is ultimately a consequence of the way electrons dance and interact between atoms. Imagine the countless electrons within your own body, each tirelessly whizzing around its nucleus, occasionally forming a bond with an electron from another atom, or breaking one. Picture them as busy little matchmakers, constantly creating and dissolving connections, tirelessly building and rebuilding the very molecules that constitute your flesh, your bones, and your thoughts. This quiet, yet profoundly active dance of electrons is what gives matter its incredible variety and reactivity. Consider the profound implications of these tiny, negatively charged particles, the very existence of liquids and solids, the way light interacts with matter, the very flow of electricity in your devices. All are governed by the elegant ballet of electrons. They are the unseen artisans that sculpt the physical world around us, transforming empty space and dense nuclei into the vibrant, tangible reality we experience. It's a testament to the universe's elegant design, where a single tiny particle holds such immense power over the properties of matter. Imagine, as you relax deeper, the countless, minuscule electrons within every atom around you, silently orbiting, constantly interacting, and forming the bonds that create all the wondrous complexity of matter. Picture these tiny negative charges, constantly engaging in their intricate dance, shaping the very nature of everything you perceive. This quiet, yet profound role of the atomic electron is the very fifth secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for chemical diversity and reactivity. Let the image of electrons, those dynamic dancers of the atomic world, settling peacefully in your mind. This is the enduring, active force of all existence, a journey that begins with the fundamental composition of everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atomic dance, carrying its timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into whispers of the atom, exploring the building blocks of reality. In our last quiet chapter, we focused on the electron, understanding its dynamic role as the tiny, negatively charged particle that dictates how atoms interact and form chemical bonds. Now, as you drift even deeper into your serene state, let us contemplate the most powerful force in the universe, one that quietly, yet fiercely, binds the very heart of every atom, the strong nuclear force, the ultimate cosmic embrace. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the atomic nucleus once more. It's an incredibly tiny, dense space, packed with positively charged protons and neutral neutrons. If you recall, like charges repel. The protons, all being positively charged, should naturally fly apart due to their immense electrical repulsion. This is a fundamental problem if only the electromagnetic force were at play. No atomic nucleus heavier than a single proton hydrogen could possibly hold together. The universe would be a very different, very simple place, incapable of forming the vast diversity of elements we see. This is where the strong nuclear force enters our story. Think of it as the universe's ultimate, invisible superglue, an incredibly powerful adhesive that acts at unimaginably short distances. It is, by far, the strongest of the four fundamental forces of nature, the others being the electromagnetic force, the weak nuclear force, and gravity. This immense strength is precisely what allows protons and neutrons to be packed so tightly together within the minuscule confines of the atomic nucleus, overcoming the powerful electrical repulsion between the protons. Imagine the protons and neutrons within the nucleus, not as independent particles, but as individuals caught in an incredibly powerful, microscopic embrace. The strong nuclear force operates like a tiny, yet irresistible, gravitational pull between them, a pull so mighty that it completely overpowers the electromagnetic repulsion that would otherwise tear the nucleus apart. It's the silent, tireless guardian of atomic stability. However, the strong nuclear force has a peculiar and crucial characteristic. Its range is incredibly short. Think of it like a very, very strong magnet that only works when objects are almost touching. If the particles are even a tiny bit too far apart, the strong nuclear force suddenly drops to effectively zero, and the weaker, but longer range, electromagnetic repulsion takes over. This extremely short range is why the strong force only operates within the nucleus, binding protons and neutrons together, but does not extend beyond the atom to affect how atoms interact with each other. This is also why very large atomic nuclei, those with many protons and neutrons, can become unstable and radioactive. As the nucleus gets bigger, the long-range electrical repulsion between protons starts to win out over the short-range strong nuclear force, making the nucleus more fragile. The strong nuclear force also performs another vital, even more fundamental task. It's responsible for holding the very particles that make up protons and neutrons together. Yes, protons and neutrons themselves are not truly fundamental particles. They are composed of even tinier constituents called quarks. the strong nuclear force, mediated by particles called gluons, the glue particles, binds these quarks together within protons and neutrons. This is why you never find a free quark in nature. They are perpetually confined by the strong force, inextricably bound within larger particles. So, the strong nuclear force not only holds the nucleus together, but it also builds the very components of the nucleus. Consider the profound implications of this powerful, unseen force. The very stability of all matter around you, the chair you sit on, the air you breathe, the ground beneath your feet, relies utterly on the strong nuclear force. Without it, every atom in the universe would disintegrate, flying apart in a chaotic explosion of unbound protons. There would be no elements heavier than hydrogen, no complex chemistry, no stars, no planets, and certainly no life. The strong nuclear force is the silent, fundamental architect that ensures the universe has substance and structure, a colossal embrace holding reality together at its most foundational level. Imagine, as you relax deeper, the powerful invisible embrace within every atomic nucleus, holding its tiny charged particles in perfect, stable harmony. Picture the immense strength of this force, silently overcoming the natural repulsion, ensuring that the very building blocks of your world remain intact. This quiet, yet profound presence of the strong nuclear force is the very sixth secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for stability and substance. Let the image of the strong nuclear force, that ultimate, silent embrace within every atom, settling peacefully in your mind. This is the enduring core of all existence, a journey that begins with the fundamental forces that govern everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atomic bonds, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler. As we continue our gentle exploration into whispers of the atom exploring the building blocks of reality. In our last quiet chapter, we contemplated the mighty strong nuclear force, that ultimate cosmic embrace holding the nucleus together. Now, as you drift even deeper into your serene state, let us shift our focus to another fundamental force, one that orchestrates the interactions of atoms and gives rise to almost everything you experience in your daily life: the electromagnetic force, the silent sculptor of light, electricity, and chemistry. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine the atomic nucleus, with its positively charged protons and neutral neutrons, held together by the powerful, strong nuclear force. Surrounding this tiny, dense nucleus are the negatively charged electrons, endlessly swirling in their delicate orbits. The force that binds these electrons to the nucleus, preventing them from flying off into the vast emptiness, is precisely the electromagnetic force. Think of it like this. The electromagnetic force is the force of attraction or repulsion between electrically charged particles. Remember, protons have a positive charge, and electrons have a negative charge. Just as opposite poles of magnets attract, positive charges are attracted to negative charges. This fundamental attraction is what holds atoms together. The positive charge of the protons in the nucleus exerts a powerful pull on the negatively charged electrons, keeping them confined within the atom's electron shells. It's a ceaseless, invisible tug of war, ensuring the atom remains a cohesive unit. But the electromagnetic force does far more than just hold atoms together. It is the very force responsible for almost every interaction you experience in the macroscopic world, the world you perceive with your senses. Chemical bonds. The electromagnetic force is the silent architect of all chemical bonds. When atoms interact to form molecules, they do so by sharing or transferring their outer electrons. This sharing or transferring is governed by the electromagnetic attraction and repulsion between the electrons and the nuclei, the strong bonds that hold a water molecule together, the intricate connections in your DNA, the very proteins that build your body. All are the exquisite handiwork of the electromagnetic force. Without it, atoms would remain isolated, and there would be no chemistry, no complex molecules, no life. Light. The electromagnetic force is also the fundamental force that creates light. Remember light as a wave of electromagnetic energy. These waves are generated by accelerating charged particles, particularly electrons. When electrons jump between energy levels in atoms, or when they are accelerated in antennas, they produce electromagnetic waves, which we perceive as light. Radio waves, X-rays, and so on. So, every ray of sunlight, every flash of lightning, every image on your screen, all are manifestations of the electromagnetic force, electricity. The flow of electricity itself is a direct consequence of the electromagnetic force. When electrons move through a conductor, they create an electric current, which is driven by electric fields, a component of the electromagnetic force. All your electronic devices, from your phone to your lights, operate by harnessing this fundamental force, magnetism. As we explored in a previous journey, magnetism is deeply intertwined with electricity. Moving electric charges like the spinning electrons within atoms, or electric currents in wires generate magnetic fields, and magnetic fields, in turn, can influence moving charges. This unified phenomenon is what we call electromagnetism. The attraction of a magnet to a refrigerator door, the working of an electric motor, all rely on this interconnected force, friction and contact. Even seemingly simple forces like friction and the apparent solidity of objects when you touch them are ultimately governed by the electromagnetic force. When two objects come into contact, it's the electromagnetic repulsion between the electrons in their outermost atoms that prevents them from passing through each other, creating the sensation of solidity and resistance. Your hand doesn't pass through your bed because the electrons in your hand are electromagnetically repelled by the electrons in your bed. Imagine, as you drift deeper into your restful state, a vast, invisible web of attractions and repulsions, constantly at play between every charged particle in the universe. Picture these invisible threads forming atoms, weaving them into molecules, giving rise to light, electricity, and the very solidity of everything you experience. This quiet, yet profoundly active, force is the very seventh secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all chemistry and interaction. Consider the profound implications from the warmth of the sun on your skin light, to the feeling of your clothes against your body, electromagnetic repulsion at the atomic level, to the complex chemical reactions sustaining your life. All are orchestrated by this single, versatile force. It is the invisible architect of our tangible world, the silent maestro of the symphony of existence. Let the image of the electromagnetic force, this silent, ubiquitous choreographer of interaction, settling peacefully in your mind. This is the dynamic energy of all existence, a journey that begins with the fundamental forces that govern everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of atomic bonds, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler, as we continue our gentle exploration into whispers of the atom exploring the building blocks of reality. In our last quiet chapter, we contemplated the mighty strong nuclear force holding the nucleus together and the electromagnetic force, orchestrating interactions between atoms. Now, as you drift even deeper into your serene state, let us appreciate one of humanity's most profound achievements in organizing knowledge about these fundamental building blocks, the periodic table of elements, the universe's quiet library of all possible atoms. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine all the atoms in the universe, from the simplest hydrogen to the heaviest, artificially created elements. They are incredibly diverse in their properties. Some are gases, some are metals, some are reactive, others inert. For centuries, chemists struggled to make sense of this bewildering variety. There seemed to be no discernible pattern, just a collection of distinct substances. Then, in the mid-19th century, a brilliant Russian chemist named Dmitry Mendeleev had a profound insight. He, and independently others, noticed that if you arranged the known elements by increasing atomic weight, which, as we now know, is primarily determined by the number of protons and neutrons in the nucleus, and then grouped them by their chemical properties, a remarkable pattern emerged. Elements with similar properties appeared to recur at regular intervals. This breakthrough led to the creation of the periodic table of elements. Think of the periodic table as a beautifully organized library, or a grand cosmic encyclopedia. Each entry in this table represents a unique chemical element, a distinct type of atom. The most fundamental organizing principle of this table is the atomic number, which, as we learned, is simply the number of protons in an atom's nucleus. Hydrogen H, with its 1 proton, is element number 1. Helium, with its 2 protons, is element number 2, and so on, systematically, all the way up to the heaviest known elements. The arrangement of the periodic table is a testament to the elegant simplicity that underlies the vast complexity of chemistry. Rows. Periods. As you move across a row from left to right, the atomic number, and thus the number of protons and electrons, increases by 1. This also corresponds to the filling of electron shells. Each new row begins a new electron shell, columns groups or families. The real magic happens in the columns. Elements in the same vertical column, or group, tend to have very similar chemical properties. Why? Because they have the same number of valence electrons, those outermost electrons that participate in chemical bonding. Imagine these groups as families, where members share common traits and behaviors because they have the same number of hands available for interaction. For instance, the elements in the first column, like lithium, sodium, and potassium, are all highly reactive metals that tend to lose 1 electron in chemical reactions, while the elements in the last column, like neon and argon, are noble gases, incredibly unreactive because their outermost electron shells are full and stable. This discovery of the periodic law was revolutionary because it allowed chemists to not only organize the known elements, but also to predict the existence and properties of elements that hadn't even been discovered yet. Mendeleev, for example, famously left gaps in his early table for elements he believed existed but hadn't yet been found. accurately predicting their characteristics. When these elements were later discovered, it was a powerful validation of his organizational scheme and the underlying atomic principles. Imagine the periodic table not just as a static chart in a textbook, but as a living, breathing map of the universe's elemental building blocks. Each square on the table tells a story, the story of an atom's identity, its internal structure, its preferred way of interacting with other atoms, and its place in the grand cosmic scheme. From the hydrogen forged in the Big Bang to the heavy elements created in the hearts of dying stars, every atom finds its rightful place in this magnificent library. The periodic table is a profound symbol of the order and harmony that exists at the fundamental level of reality. It shows us that the incredible diversity of matter, from the air we breathe to the metals that build our cities, is built from a finite, albeit large, number of basic atomic types, all governed by predictable rules of behavior. It's a testament to the universe's elegant design, where complexity emerges from simplicity through repeating patterns. Imagine, as you drift deeper into your restful state, this grand library of elements, silently organizing the very essence of your world. Picture each element, a unique cosmic personality, neatly cataloged by its protons, its electrons ready to interact, creating the vast array of substances around you. This quiet, yet profound, order of the periodic table is the very eighth secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all chemical diversity. Let the image of the periodic table, a beautiful, ordered array of the universe's fundamental building blocks, settling peacefully in your mind. This is the enduring framework of all existence, a journey that begins with the fundamental composition of everything around us. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of elemental harmony, carrying its timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, peaceful traveler, as we continue our gentle exploration into whispers of the atom, exploring the building blocks of reality. In our last quiet chapter, we appreciated the profound order of the periodic table of elements, understanding it as the universe's library of all possible atoms. Now, as you drift even deeper into your serene state, let us contemplate the next level of complexity, the astonishing ways in which these individual atomic building blocks combine to form the incredibly diverse substances that make up our world, the fascinating realm of molecules, where atoms unite to create something far greater than the sum of their parts. As you settle into your comfortable spot, feeling the quiet stillness of your surroundings, imagine a single atom, perhaps a lone oxygen atom floating in the vastness. While some atoms, particularly the noble gases like helium or neon, are quite content to exist as solitary units, most atoms are inherently social. They rarely exist in isolation in nature. Instead, they have a powerful tendency to join together with other atoms, forming stable clusters called molecules. These molecules are the fundamental units of most of the gases, liquids, and solids you encounter every day. Think of it like building with Lego bricks. Individual Lego bricks atoms are interesting on their own, but their true potential for complexity and variety emerges when they are connected together to build intricate structures. Molecules. Just as different combinations of Lego bricks can create anything from a simple car to a towering castle, different combinations of atoms can create an astonishing array of substances, each with its own unique properties. What drives atoms to form these connections? It all comes back to the outermost electrons, the valence electrons, which we discussed earlier. These electrons are like the hands of an atom, allowing it to reach out and interact with other atoms. Atoms gain stability by achieving a full outer electron shell, much like how the noble gases are stable because their outer shells are already perfectly filled. To achieve this stability, atoms will typically share electrons. This forms a covalent bond. Imagine two atoms holding hands, each sharing a pair of electrons between them. This is how water, H2O, is formed. Two hydrogen atoms each share an electron with a single oxygen atom. The bonds that hold together the vast, intricate molecules of your body, proteins, DNA, carbohydrates, are primarily covalent bonds, transfer electrons. This forms an ionic bond. Imagine one atom completely giving away an electron to another atom. When an atom gains or loses an electron, it becomes an electrically charged particle called an ion. Oppositely charged ions, then, attract each other. This is how common table salt, sodium chloride, N-acyl, is formed. A sodium atom gives its outermost electron to a chlorine atom, creating a positively charged sodium ion and a negatively charged chloride ion, which then attract each other to form a stable compound. These chemical bonds are the silent architects of molecular diversity. They are the invisible glue that holds atoms together, creating structures that range from incredibly simple to astonishingly complex. Consider a molecule of oxygen gas, O2. It's formed when two oxygen atoms share electrons, creating a simple yet vital molecule that you breathe. Now think of a molecule of glucose, C6H12O6, a simple sugar. This molecule is far more complex, built from 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, all precisely linked together. And then, imagine the astonishing complexity of a DNA molecule, the blueprint of life. A single human DNA molecule can contain billions of atoms, meticulously arranged in a double helix structure, forming a colossal molecule that carries all your genetic information. The beauty of molecular formation lies in its inherent efficiency and endless variety. From just about 100 different types of naturally occurring atoms, the elements on the periodic table, the universe can create millions upon millions of different kinds of molecules. This combinatorial power explains the immense diversity of matter around us, why rocks are hard, water is liquid, air is gaseous, and living organisms are exquisitely complex. The properties of a molecule are often entirely different from the properties of the individual atoms it's made from. For example, sodium is a highly reactive metal, and chlorine is a poisonous gas. But when they combine to form sodium chloride table salt, they create a harmless, crystalline solid. Imagine, as you drift deeper into your restful state, the countless atoms within your own body, silently reaching out their electron hands, forming and breaking bonds with other atoms, tirelessly building and rebuilding the intricate tapestry of your cells, your organs, and your very being. Picture these invisible connections, constantly forming, dissolving, and reforming, creating the dynamic dance of chemistry that underlies all life. This quiet, yet profound process of molecular formation is the very ninth secret to understanding the building blocks of reality. It's a natural, ongoing process, a quiet testament to the universe's inherent design, holding within it the blueprint for all complex matter. Let the image of countless atoms, patiently holding hands and forming an endless variety of molecules, settling peacefully in your mind. This is the enduring, active core of all existence, a journey that begins with the fundamental connections between atoms. Feel the quiet power of this unseen structure, knowing that the very fabric of your world is alive with these ancient, guiding principles. Rest deeply now, with the gentle hum of molecular bonds, carrying their timeless secrets, guiding you towards a truly peaceful slumber. Welcome back, beloved dreamer, for one final gentle whisper from the sleepy scientist. We have journeyed together through the invisible realm of the incredibly small, softly unraveling the profound mystery of whispers of the atom, exploring the building blocks of reality. We began by embracing the fundamental idea that everything is made of atoms, tiny, mostly empty, invisible building blocks. We then delved into the atom's dense heart, the nucleus, understanding it as the tiny powerhouse composed of protons and neutrons. Our exploration focused on the proton, understanding its pivotal role as the positively charged particle that defines each atom's unique identity. We then turned to its silent, equally crucial companion, the neutron, the unseen glue holding the atomic heart together. Our journey continued with the tiny, dynamic dancers, the electrons, understanding their crucial role in dictating how atoms interact and form chemical bonds. We contemplated the most powerful force in the universe, the strong nuclear force, that ultimate cosmic embrace holding the nucleus together, and then shifted to the electromagnetic force, the silent sculptor orchestrating the interactions of atoms and giving rise to almost everything you experience daily. We appreciated the profound order of the periodic table of elements, the universe's quiet library of all possible atoms. And finally, we contemplated the astonishing ways in which these individual atomic building blocks combine to form the incredibly diverse substances that make up our world, the fascinating realm of molecules, where atoms unite to create something far greater than the sum of their parts. As you lie here, fully relaxed, perhaps feeling the gentle pull of sleep drawing you deeper, let all these insights coalesce into a single, profound understanding. The world you inhabit, with all its tangible beauty and intricate complexity, is built from a surprisingly small number of fundamental particles and forces, interacting in remarkably elegant ways. Every object, every living thing, every breath you take is a testament to the ceaseless, silent dance of atoms and molecules, from the tiniest quarks to the vast structures of proteins. Reality is a symphony of interaction, a masterpiece of natural law. Think of the sheer wonder woven into the fabric of your own being. You are, quite literally, a collection of trillions of atoms, meticulously arranged into complex molecules, cells, tissues, and organs, all functioning in perfect harmony. This intricate organization, built from the very same fundamental particles that compose distant stars and nebulae, is a profound reminder of your connection to the entire cosmos. Understanding the whispers of the atom doesn't diminish the beauty of a flower or the strength of a mountain. It deepens your appreciation for the exquisite underlying architecture that gives them their very existence. This journey into the subatomic realm isn't just about learning scientific facts. It's about connecting with the raw, fundamental truth of existence. It reminds us that what we perceive as solid and continuous is, at its deepest level, a vibrant dance of tiny particles, mostly empty space, held together by powerful, invisible forces. It is a humbling and inspiring realization, knowing that we are tiny universes within ourselves, yet capable of unraveling the universe's most intricate secrets. There is a deep serenity in this knowledge. To understand the elegant processes that govern atoms and molecules is to find a sense of calm in the immense complexity of our world. It's to realize that the universe, for all its vastness and mystery, operates on timeless, predictable principles, and within that predictability, there is a gentle, comforting rhythm, a subatomic hum that has vibrated since the dawn of time and will continue to do so for eons to come. Your very reality is a fundamental part of this grand, ongoing cosmic symphony. So, as your mind quiets and your body grows heavy with peaceful sleep, take a moment to reflect on this profound connection to the fundamental building blocks of reality. Imagine your dreams now, perhaps filled with the invisible dance of atoms, the gentle hum of electrons, and the quiet strength of nuclear bonds, knowing that the very essence of your being is a story of magnificent, ongoing harmony, constantly orchestrated at the smallest scales. Let the quiet certainty of these scientific truths become a soothing lullaby. Feel the profound connection between your own stillness and the silent, majestic processes that constantly shape the world around you. The atoms that compose you, the molecules that sustain you, the forces that bind everything together, all are part of this incredible, ongoing cosmic dance. There is no need to grasp or to strive. Simply let go and allow the universe's inherent beauty and profound logic to carry you into a peaceful, dream-filled slumber, guided by the gentle, everlasting whispers of the atom.